This will be the construction, and a lot of this is going to be a learning curve. Um, Ernie brought up last time we had this. If you can go to somebody's shop or maybe check county systems if they have adult education and any shopping, I would strongly suggest doing that before you plunk down any money for a heavy machine tool to make sure you like this and it's something you want to do. When you start this, take notes, lots and lots and lots of notes, what you're doing, because you don't want to go back and reinvent the wheel when you've done something successfully. If things didn't work the first time, make notes what's wrong and what you did to correct it. But make sure you understand exactly when you say you want to make another engine 2, 3 years from now, and you pull out your notes and you look at it, okay, this is how I do this is how I do this, and you have the notes there for you already, so you don't have a big learning curve. You don't want to start with this. You don't want to start with a locomotive right off the bat. You want something simple. I started with number of engines. I had a South Park layout, and I had 3 engines that came out of the box, and the other 7 were in various stages of modifications, and some of them were quite large modifications. This is a Bachmann engine, and I just scraped off the cab and added walnut to make it look like a real one, but what it was, that's what they're covered with. But also you can go to the domes. This is fairly easy to make. This is something you start with. And this is just taking a round bar stock and cutting it down and making your various flutes on it. It's reasonably easy to do. There's something like the smokestack is outside is, yeah, it's not too awfully difficult, but then you have the issue of having to bore this thing out and clean up a lot of the metal out of here. And you can see it's on various angles. So that makes it much more difficult. That's something you don't want to start with this. You want to go to the domes or some other simple project. You have to have a plan. You have to have some type of system to work from. This is the South Park's first engine to Fairplay, and I got most of the information from the Union Pacific inventory they did in 1885, which gave the size of the drivers, the wheels on the tender, and the front truck, and also the length of the flues, so you know how long the boiler system is in here. And there's also some pictures of the engine that are very discernible. It's a very, very bad picture, but there are also other engines made in the period of the same type, and you can go from there. But you have to have the plan to do it. This is the Fairplay made. I did this as my first scratch build engine. I used K&S brass. No, don't want to do that. This is before I had a mill. Made it a lot more difficult. I was able to make the bearings on the lathe, but no springs. You don't want that either particularly, but it worked. It's okay. And when you get done with the thing, somebody asked me one time, where do you start on this? Well, if you look at a factory, like you go to Schenectady or Baldwin or whatever else, they have a place where they make boilers and they have a place where they make the drivers and the frame and they make the tender someplace else. All this stuff comes together to make the engine. And that's exactly what you're going to be doing, because this is a very precise mechanical device you're building. And so every piece is going to be put together as the plan shows. And so when the time comes to put together, it goes together. I have an article I put up for MR in a book about a year ago on building from photographs. And most photographs of locomotives are like the top one. They're shot at an angle and present some problems, of course, with the sizes, because these drivers are all the same size physically, but in the picture, they're not. And so if you're doing the measurement on how high this dome is, your best bet is to figure out how wide the driver is and then make some calculations what this is. But what's really neat, good, is a side shot. And this is what I have. I built 2 Baldwin 10-wheelers from this picture, and it gives you all the layout on all the particular sizes. You just simply figure out what the size of the driver is here, and then you do your multiplication table back and forth, your ratios to find out how big this is, and how many times I got to do this to come up with certain sizes. Okay, we're going to go to the frame. This is something where you're going to do a lot of mathematical figuring, and it's going to take several days to go through this and come back to and look at it. There are several things in here that are absolutely crucial, and other things are simply cosmetic. What is the true position? Everything I measure Every time I measure something, it comes from the tail end here of the frame, the back end. And this is where all your measurements can be taken from, is from the back end. And what you're going to do is to put this is the hole for the drivers here. And you want to make sure these are size enough for the axle you're going to use and the size of the bearing. Whatever that is, so you want to make sure that's what it is. And when it comes time to measure to cut the hole, you measure from here to this point here. And then you put the bearing, fill this in. And from here to do this one. And from here to do this one. And from here to do the saddle. You never go from here to here. Never, ever, ever do that. Also remember when you're doing the saddle that the piston rod is above the driver center. So you need to figure out how the driver is going to be on this and how high you make that. You don't make it too high, but it has to be slightly above the center line of the drivers. Also, when you do this, you want to sit there and calculate this thing backwards and forwards, sideways and up, down, here to here, here to here. No, sorry. Back and forth. The question is, you want to sit there and do all the mathematical calculations when the front, midway, front to the back to the front, back to midway, back to a 3/4, 3/4 back to a quarter, and make sure all the numbers work out each time you do it. You don't want to make a mistake here because that's going to really mess you up doing the frame. You want to make sure all the numbers work out. These openings here, 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 and here are simply cosmetic. You don't want to do those until you actually have the bearings and things cut. Also, remember again, the saddle is here. You can buy this commercially, this piece. The cylinders, ends, the sniffer valves are not available. I mean, they're available through, you've got to make them, or you can buy commercially. But this saddle business here comes as one unit. You have to buy this stuff too that also fits. You can make changes in this, but this has to fit. So this right here, this has to above the driver center, and this has to fit under where the smokestack is, because that's where the exhaust jet goes up into the petticoat pipe, up into the smokestack. Before you make the frame, before you start anything, you want to do the bearings. You want to make sure you have the bearings in hand and how they're done. Now, these bearings are trash. That's the reason why they're in this picture. Otherwise, you would have used them. So you'll see some aberrations thing. That's what the problems you have. You take a piece of round stock and you cut a hole in here, and this is for your axle. You want the thing to slide smoothly, no slop. Don't want it to be too hard, but you don't want any slop. Then you take in the mill and you grind off here and making sure this part right here and this part right here are exactly the same. No variations in the thing. And you cut the other side here and you wind up with a bearing like this. And this is drilled for the spring. These distances have to be exactly the same. These two are the same and these two are the same. And you have, let's see, in your mill here, you have a lock bar here. See this thing right here? This is, let me make a better one than this. On your mill, you have a lock bar here, so the thing can only go down so far. You have a turning wheel right here that gives you a very fine movement. This big wheel is too much for most things when you're actually doing machining, but you can use the knob here and it gives you very slight changes. And this will lock it once you get it in there. You also want to make sure this is very tight, because cutting the metal, it will pull the bit out of the chuck if you don't tighten it down enough. Oh, there it is. Okay, sorry. This is your wheel here, and this is your major movement of the thing up and down. And you have a wheel on this side over here that moves the thing from left to right. Cutting the frame. Again, this is the frame metal here. I use 1/8 by 1 inch, and it depends on what size of locomotive you're building, what scale, how thick brass you're going to use, what size brass you're going to use. And what you do is this is your fixed position, and you scribe a line here across the openings for the bearings. This will be just a rough line. And what you do is you bore a hole in this in the middle and begin to work your way out. And as you get near the line here, you set your caliper. Say this is 1 inch and 400 thousandths. So you set your caliper at 1 inch, 400 thousand and lock it in place. And you open this up until the caliper slides down like a knife through hot butter, or a hot knife through butter. It doesn't slop and you don't want the drag. Then you work this side until the bearing fits in the hole. And you leave this closed. You never open this up at this point. Then you do the same thing with this. You measure from here to here, and you fix this, and as here to here to do this one. Each one of these is exactly the same. I have built 13 locomotives. That's 26 frames. I never made a mistake in these things, never threw one out. You cannot do two at the same time. The metal in your mill end is steel, and it's like a drill bit to a certain extent. It will bend, and you're asking too much to cut two at the same time. You cut one at a time, and believe you me, it's not that bad, and it goes fairly quickly. Not that. Again, these holes here are simply cosmetic in the frame, and this is, of course, for the saddle. This is for a 10-wheeler. Now, go back to the frame, open it up. The bar right here is your bearing cap. This goes under where the bearings are going to be. And what I do is I drill a hole through this into the frame for an odd 80 screw. Okay. You take the thing off, you clamp it. Okay. You take the thing off, and then you tap your holes here in the frame for the odd 80 screws. And then you take your cap off and you drill it out so the screws go through it snugly, not hard, and no slop. Screw it together, make sure it comes together all right, and then your bearings are set, the openings are set, and then you can open the frame up. Then you take this and remove the metal that is left here. But you don't do that until you actually put your bearing cap across it and put the screws in, and it's all set to go. And then you cut the frame open. This is the frame finished with all the parts to it. Here are the bearings with the flange out. So the between space the drivers away from the frame, no shorts. The springs, and this is all nice and open, so you can look through and see the other side as in the prototype. And again, the cylinder block up here, this is above this line here. When you come to put the spacers in, you want to figure out how wide the opening is for your drivers and what this distance is in here between this and the other side. And you want a little slop, not much, but you want some slop to it. So there's a little play laterally in the drive frame. The motors, I always, people mount motors differently than this, but this is what I did. I always mount my motor backwards. So the gearbox sits on the rear axle and the motor's up in the boiler. And what this gives me is a clear open frame with no gearbox showing in here. Here it is on a consolidation. This is the gearbox here, and the motor is up inside here. One of the nice things about this is it's easy to get to and deal with, but also if you need to add weight to the engine, go to a roofing store and buy yourself a bar of solder for people who work with copper roofs. Comes in a bar. And what you do is you cut a piece off and you can put it down inside where the boiler is here, and you stick your resistance soldering in there on the solder only, not on the brass, only on the solder. Solder melts and cools, let it cool, and you got a nice weight to it. You can also add more weight to each side of the boiler by having this out and doing the same thing. But make sure you do not put the soldering iron on the brass. You want it only on the lead if you're adding weight. Again, here are the caps. for the bearings. Okay. And one other thing we'll get to here is the side rods. These things are threaded screws, and you cannot leave them exposed to the movement of the side rod. There has to be a bearing surface. And what I have has odd screws in their heads. When it gets into here and the one up in here, we'll probably have to shave off part of the head because the clearances are really quite tight. And if you look at most models and even my live steam engine, the bolt in that was basically countersunk into the hole. So for clearances reasons. But how do you get a surface on the screw? Well, that took a little figuring for me, but through online metals, you can buy a brass rod open tube like this. And the outside is 125,000 and the inside is 50,000. And the screw is 58,000. So what you do is you take your boring bar and go in here and open this up just enough for that screw to go in cleanly. And then you cut it off so it's a little longer than the thickness of your journals. And bingo, there it is. Drivers, we're going to get into something here that is rather ticklish, and this is going to seem like more work than may be necessary, but I believe you me, this is the way to do this. You can buy the castings, and there's usually from precision scale, there's a demo where you can drill through that, but we'll get to that in a minute. What you want to do is you want to make these. This is a brass rim, and these are the steel tires. This is your 360 brass, and this is your 12L14 steel on the outside. Close up, here again is the brass rim and the steel tire. This is the same thing, but the steel tire is a little thinner, and what I have in here is the installation. You can see it right in here. And when you press the installation in and cut it off and clean it up, you want to take something like clear nail polish and flood into the connection. You want to make sure there's no place for any shavings, clips, pieces of brass to fall in here and cause a short. You want to check this with a ohm meter first to make sure there's no conductivity through here. And then you want to put your nail polish on it. Again, check it, make sure there's no conductivity, and then you're done with this. This is rather crude. I mean, I drew this on the desk when I was building this thing, This is your casting, and this will fit snugly, but finger tight to the brass rim here. And this will be pressed onto the steel tire here. And this is what is pressed onto this. This is the face of the tire, and this is the end of the flange. As I said, when you have the installation, the Mylar is 3.5 thousandths. And I usually use 2 layers, so you're talking about 7 thousandths. So you want to make sure when you're cutting this, when you're cutting the inside of the tire, you want to cut it down maybe 6,000, 5,500 thousandths. So you have enough that's snug but not too tight. Because you don't want to. Okay, well, let's get to this. This is what you're going to start with, is a piece of brass like this in a lathe, and you're going to cut it down to this, which is a lot of cutting. But this is what you need. This is the rim, and then here's the tire. And these are pressed together snugly, but not too much because the metal is thin. It's not particularly heavy. Again, here's the steel tire. There's a blind. Here's another one I did for another engine. It has a flange on it. And here are the two pieces together. And here's one that fit too tight. And bent it. I just bent it the hell out of it so I wouldn't inadvertently pick it up. If it doesn't work, chuck it. Don't put something on there that's sort of screwed up and say, let it go. You can't do that. You want to make sure it's exactly right. Here I've been building 3 engines at the same time, and here are all the tires and rims all ready to go. And here are the wheel castings. And now we're going to get down to something that is, I'm going to have to talk you through this slowly, but I think it'll be clear. What you have over here is the tire, the rim, and the wheel together with the axle. You have these two, the tire and the rim together, and now you want to do casting for the wheel center. This is an operation you are going to do. You're going to put a piece of brass in the lathe here like this, and it does not ever, ever, never, ever come out until you're all finished with all the drivers as I step through what you're going to have to do. You cannot put this back in the lathe correctly. It has to sit there until you are completely finished making all the driver centers and mounting all this stuff. Okay. So what you do is you put a piece of brass in here, round brass like this, and you put a face on it with a small stud sticking out from the center of the brass. So it would be sticking out from this area right here. You want that brass stud to be able to be drilled and tapped with a 256 screw. It's going to hold your wheel in place for casting. When you drill this out, you make sure this is small enough, smaller than the axle, and you want to be able to accommodate the stud with a screw. If you want to use a different size screw, that's okay, but you want to be able to have the accommodate a screw with a washer on it to hold this against this while you turn it, and there's gonna be friction, so you have to that's be a hard fit. With that in place, the stud also is going to be a little less of a distance than the thickness of the driver. Now my drivers are 135 thousandths thick, so we want to make the stud maybe 120,000. But you just want to make sure it doesn't matter. You don't have to measure it, but you want to make sure it does not stick out past the face of the driver. So when you have that made up, you put this on unfinished with it been pre-drilled onto that stud, put the screw on there, tighten it down, and then you take your lathe and you cut across it until you have a nice smooth finish on the outside. Then you take it off and flip it over. Don't pay attention to this. We're not there yet. You flip it over and you cut the back side. Now, because the tires are 135,000, the thickness of the wheel is going to be 135,000. So you want to measure that what that is and cut it down to that. When you are finished with that, then you flip it over. So you have this out again. And it's best if you put 2 screw holes through the spokes to lock this in place, because you're going to be doing some really cutting on this. Lock it in place, and then you proceed to finish the outside of this, and you want to bring this down so this driver center fits snugly on this. It's a finger fit, no slop, but no pressing either. You want it to finger fit, and that's that part of it. Let's see. This is show you what it is. Here is another driver I had. This is the casting here, and this is the rim, and there's the tire. So you want to do that. When that is done, you take the casting, you've machined it all off, and the rim and the tire, put it on a flat surface, and you want to solder together. And the heat is not a problem with the Mylar. You don't want to overheat it, but you want to put enough heat to make sure it's soldered. You can also use something like Loctite to help ensure a permanent fit. But you also want to make sure there's electric continuity between this and your rim. That's the reason why you do it this way, because you can solder this thing. Okay. Then when you have this finished, then you take your lathe and you cut that stud off. You put a big drill hole through the middle of this thing, and this will be bigger than the axle. And then you begin to bore this out. So the driver fits into the face of this. It sits rest on this, and the flange sticks over top of this. It's just like this. And then you bore out this for the axle. Don't ever use a drill bit. You have to bore it. The drill bit will not be straight and it'll flip around. The boring bar is what you need to do. And of course, you want to make sure that this will get pressed. So you don't want to overdo the cutting. Again, this is the piece I was showing a minute ago. If you have a casting where you have to take all the rim off of it, you want to solder a plate on the back of it for each axle because these will just bend if you try and machine these off. Now I had those 3 inches I was showing you. I used the same driver center, but the original one was this is 60-inch driver, and the other 52. So I had to cut down into this, and so I had to put a plate behind it and solder this so they don't bend when I machine it. Now we get to the side rods. This is one of the questions I never quite understood until I started doing this. How do you locate where the side rod goes on the side here? Okay, actually it's quite simple. What is the distance across your axle going to be? Mine's 3/16. So I take half of that, and then I find out what is the distance of the piston travel. Say it's 24 inches. So you take 3/16 and half of the 24-inch thing and scale, and you measure down from here on with the caliper, and you scribe a line, and that's where it goes. Then you take a punch in the center of that and put a little punch in there, drill it out so you can tap it, whichever screw you're going to use, you tap it for that. And then you have this tool here to tap into this. So you must have a tool like this or something same nature, because the tap will, when you start tapping something, it'll cock off to the side. You can't allow it to move. If it does, you're going to be changing the distances as the screw is at an angle. As the driver goes around, the distance is going to keep changing back and forth. So you want to make sure this is perpendicular in the hole. Smoke box. Again, this is another operation like the rims. You are going to be using a big piece of round stock, cut the outside, then you spend hours boring this out. Now, one of the things to pay attention when you're boring this makes it easier and safer for you is use a gauge because you can't see in here where you're boring. And what I do is I drill the hole all the way through as far as I want to. And then I take the boring bar and I run it in that hole as far as I want to, or as far as the tool will go. And then I will set the gauge here. Now, see, this is set somewhere between like 80, about 85,000. It's off the end. I put it against the edge here, and I will push it around one full revolution back to 0. So this gauge will read 0, and this gauge right here will read 1 down here. And that'll tell me how far I need to go in. So I back the thing out, set it to cut, and I run in. And when I get near the distance, this engages and it goes around, tells me it's engaged. I'm getting near the end of where I can go. And when it comes around to 0 again, that's where you stop. Then you back it out. And then you set it again to cut another one, and you go and do the same thing. Once the thing engages, it goes to 0, and you pay attention, it goes around to 0 again. That's where you stop. There's no guessing. This is about as fail-safe as you can get. If you try and say, well, I would go 2 in or go 3 in, you're going to forget what you're doing, and that's not a good way to do it. Not a good way to do it. If you're doing a smoke box with rivets, you need a dividing plate like this. This is available from a Micromart. And you set this up, put your thing in here where you're gonna do it, and you use a starter bit, and you put a little dimple, and then you crank this thing around. There's a sheet that gives you the information how many rivets you have in a circle, 20, 50, 60, whatever it is, and how many times you turn this and where you leave it. It's very simple to follow, although this gets rather repetitive and getting boring, but you don't want to forget what you're doing. And you go through and you put your center drill bit and put a dimple all the way around, take it out, and then you put your bit in that you're going to use for the rivets, and you drill it through. And a nice thing about this Albrecht chuck is you put your thumb and finger on this and you feed this by hand. It goes down. This just slips and it goes there. I never broke a bit with this thing. And I know it's expensive. I know when I bought it, it was about 350 bucks and it's nothing going up in price, but this is going to save you bits off the galore and it's really nice to use. One of the things to be careful about this is make sure you pick the right size rivets. I screwed up on this one. The rivets are way too big. So you're doing this work, make sure you have the right size rivets before you start this. And also make sure you pay attention to your counts because see here, I got lost in what I was doing and the rivets were off and these two are trash. This is what I'm talking about, the issue of patience. You are going to have some failures in this, so be prepared. The boiler. This is made of 16,000 brass. Anything thicker is going to be too heavy, and I think this is about the best thickness you can get. And what I do when I'm making the smoke box here, I will cut off several rings. There's a ring there. You see where I'm pointing, okay? I put a ring inside here and a ring here for this one. These are wagon top boilers, which are much more difficult to make than shotgun, which is straight. You might want to start with a shotgun boiler for simplicity. I also make rings for here, here, and in the middle. And here are the rings here. There's the ring there, another one here, and there's one in here. And this is set back just far enough for the smoke box to go in and be permanently mounted straight there. Now, when you get the brass, it's going to be hard to bend this thing. And what you do is you work at it for a while to bend it. And this is where your radiator clamps come in thing. You tighten these things down and work it down to clamp the brass into the circle around this, and then you can solder it. You also make sure when you figure this out, use your pi formula to figure out how long this piece has to be to go around it and stop where you want it to. This I opened up. This is where the firebox is here, and this is open for the motor up in here. This particular piece here, this type of boiler, this is flat down here. This is not a cone. This is a flare thing, which makes it much more difficult to do. And this has to be fitted by hand. When you're doing the ring here, make sure the ring has a step on it, a little smaller, so this thing doesn't lap up over top of this. Other parts of the thing you're gonna do drawings. This is a Colorado Midland cab. I wanted to make sure the cab was the windows and side panels were exactly right, so I blew it up 200% and did all the calculations. One of the problems I didn't buy HO was that the cabs and the windows were not correct or grossly out of shape. And I want to make sure I achieve that particular Midland look on this. And this is what you need to do for your drawings for the sides and the ends, front and back ends of the cab. And there the cab is finished. This is just another sheet added on the inside of this. That's all this is. You do in the front where you have maybe 3 layers. Again, you're actually soldering another layer of brass on the back of what's there. Be careful when you're soldering pieces together like doing the cab. I got too much heat on this thing and it welded. This is a tender I was doing and I couldn't get the pieces apart and it ruined it. I had to do it all over again. So be careful you don't add too much heat, too much solder, but enough to hold it together. The domes. These are fairly simple. This is where I would suggest starting. Depends how complex the dome is you're going to use, but this is simply a round piece of brass stuck in the lathe and you turn it down. So far you get this, so far to get the rings on it, so far to get where the safety valves and the whistle go through. Same thing for the sand dome. I did a drawing, just a very crude drawing, but all I needed were the numbers. And you simply cut into the brass to do your rings and your however you want to do this. And this one has more complicated. You have a band here and a band here, and this goes in. This is inside here. This goes round, and this gets cut here and here and that. And when you're doing the domes, now on the prototype, the domes are mounted on the boiler, and the sheeting here goes over top of it, goes around it. So, but with the modeling, of course, the domes go on top of the sheeting. What I do is I make sure this is extra long, extra space down here. And what I do is I turn this around and I will bore this thing out in the center and make it a thin ring around the outside. Then I'll take a Dremel tool and begin to work at it, cutting it down to make sure it fits. When you put the jacket on, there are going to be aberrations. It's not going to be a complete smooth surface ring like you would turn a piece of brass for the smoke box. It's going to have some peculiarities to it. And so when you're cutting with the Dremel tool, you want to make sure you work at this. And this takes a while, but it works very nicely. Oh, also one of the questions that came up, like, how about using tube brass or how about using tubes? No, it's a different alloy. You cannot use tube metal for machining like this. So you take a piece of pipe and say, oh, I got a piece of copper pipe for my plumbing that I can do same size as this. Can I use that? No, it's not the same type of material. It will not take a tap and you can't cut it. If you're doing this smoke box, it's the same thing on your pieces. This fortunately was purchased. This worked for me very nicely. I added the railing on there and the number plate, but all the dogs and all the rest of the stuff are already on here. When I did the Midland though, the 10-wheelers from Schenectady, I had to make my own. And that includes, all the rivets around the outside, making the dogs and making the hinges. And again, this is something similar to doing the dome. You simply take a piece of brass and you cut in the inside where it's going to go inside the smoke box. You cut into here to this, you cut into here to this, and you cut into here to this, and then you smooth it out. There are various tools you can use, your cutting tools that do some of the curved work on this, and some of this can be done with a file. I just take the nice machine file, I put it in the lathe, turn it on, and hold it very securely, carefully, very carefully, and let some of the file do some of the work for me and clean it up and make nice curves. The tender. This is fairly straightforward. This is a piece of thicker sheet brass. It's like 32 thousandths or maybe even thicker. I use a round piece of stock for the bolster. These things are screwed together with 440 screws. Again, this is just sheet brass or bar stock for these things. And of course, drill it out before you do it too far for your speaker, if you're going to have a speaker in the tender. Oh, let me see. Before I get this, one of the issues I had with the engines were that because we're dealing with 19th century locomotives with very long cow catchers and these things stick out very far, this is not insulated. These are brass couplers. These are prototype couplers, brass, and I can't insulate this. So if I were on a double header, that leaves me with insulating the tender coupler. And so I used a piece of, what do you call it? Styrene, cut it and make sure it says it's on all four sides. And I use a plastic screw to go through here. So there's no metal to metal contact and the couplers are, completely insulated from each other. So you can run double headers. Doing the wrapper. Now, again, this is do 19th century locomotives, and this is how this would be done for this. How you do the wrapper? Well, you figure out how big the plate is for the top and the bottom, this piece here. I take a piece of tube brass. You use tube brass for this. You don't want to use bar stock because a piece of brass that thick and that heavy is too much weight, unless you want the tender to weigh a ton. This is just a tube brass here, and solder this in here, one here, one here, and here. And then you begin your measuring. This is where you get your pi formula. And to figure out how much brass you need here, I add 610 thousandths to go back into the bunker, 620 thousandths to go around this, halfway around this curve. This is 4 inches and 5 thousandths down the side. Again, this is a quarter of this is 3/42. This is what is straight from here to here. And again, here, again, and again, and again. And you come up with the thing at 12 inches, 304 thousandths is the total length of all this for your brass. And you also know the distances here. This is where your bending tool I suggested that you might want to look at. Anybody who works with copper roofing uses a tool like this to bend stuff because it has no teeth on here, so there's no marks left on the material. Here is the tender wrapper for this particular one. This is the first one I built. I would not use this small of brass anymore. I use full to cover the whole thing around the corner and wrap it around. And this is cut for the corners because you can't do the flare with what we have at our house are available. This is bent with the tool I just showed you. And here are all the rivets in place for each of the corner. This goes here, right on this side here. Whoop. And this will go down the backside over here. This is on the backside of the tender, and this goes into the water, around the water legs. This is another one I did. This is what the last iteration I did on saying this is where the cold bunker goes. This is opened up for the speaker and whatever else. And you take your piece of brass that you've already had all your material put on. You figure out exactly where the middle is, and then you figure exactly the middle of where the tender piece is here, and you tack solder it. Make sure it's square on the square to the tender, and right in the middle of it is. Check it and check it, and then you bend it around and you solder it as you go around and feed the piece in. And doing the rivets, what I do is I had a piece of steel and I would cut it so there's a lip up here, so it can't go up into the chuck. Otherwise, you keep pressing it, it's going to push it up into the chuck. So you have to stop it. You have to put a lip on this so it stops at the jaws of the chuck and won't go up. And it goes down, and there's a little stud on the end of this, and I press this into a piece of soft metal, or you can use a pre-made piece with holes drilled into it and press into the holes. And this is moved down a gauge on the end down here, or you can use a caliper gauge to move this thing. How many inches or how many thousands you want to move it to get this your rivets exactly the distance you want, so you all wind up exactly like. And this is the first one I was showing you. This is the tender without the pieces on here. Goes around the water legs. And here it is completed. And what this piece is here is done by hand. This is going to take you a little while of trial and error, cutting and fitting. And you will make sure this thing fits exactly in this hole and matches the two ends and matches the base. And you solder it very carefully and file it off and make a nice corner to it. This is a completed tender. And again, you have all kinds of stuff here. This is made up from tube brass. The water drain in here is available from precision scale. The water tank lid is precision scale. The ladder is also from precision, but it has to be greatly modified to go through here like this. Here's your coupler pocket and your pulling pockets available. Your water leg valves here on both sides, and toolboxes if you want those. Again, here's the engine completed. And again, your flared pieces here, and you put a nice piece of wire around there from precision scale. They have different sizes, and you solder that on. We've got a nice little top to your rim. Also, when you're doing the engine, you're going to have lots of little pieces to put together. You know, drill here for the step up to the sand dome. This air tank here, all this was installed rivets, and that was not an easy job. Toolbox. You have a drain thing here in the front under the smoke box. Here's the access to put water in here and flush this out without opening it up. And this is the drain for that. And you also have your piece here for your spring mechanism for the front truck, your flag mounts, couplers, all that kind of stuff. All this stuff comes out and makes a real nice locomotive for you. A lot of the engines in the 19th century would have the injectors outside the cab. And you put your pipes on there and away you go. The other one I had back in the Bachmann engine, the feed water thing went up into the steam dome, which is quite unusual. Also notice here, we don't see any gearbox. We don't see any motor. It's all nice and clean. Again, start off with something that's simple, like a dome, and take lots of notes, and away you go. It makes a nice engine. The first engine I built for the Midland. I want to make sure before I started tearing the old layout out that I could do this and get an engine I wanted. And I exceeded my fondest dreams when I finished this thing. This took about 10 weeks to do. Okay, any questions? Anybody still there?
Yeah, I do have a question. This is Gil Fuchs. I actually used a method for, and I just wanted your opinion on it, for the base of the domes. I used fly cuts to basically cut them a little bit round shape so they can sit on the boiler, right?
Okay, what I do is I cut the dome and let's see. I make this all up here, okay?
Right.
Okay. This is a longer piece of brass because I leave it longer than needed.
Mm-hmm.
And what I do is I put this back in the lathe, this part in the lathe with this end facing the cutting tools and where the drill bit would go. And I will cut out, ream out with a boring bar, this in here, up to about here. So I can have a little lip all the way around and make it easy to cut away. So this fits down on top of the boiler jacket.
Right. I read this in the book, and I've actually tried it, and it worked pretty well. I actually put the tool in the chuck, and I mounted the dome, sideways, and basically bore into the dome. It's
From the
called a
bottom.
fly cut. Fly
From the
cut.
bottom.
Yeah.
Yeah,
Yeah. Bottom of
there
it.
there are different ways to do this. But the thing is, what I'm trying to explain is what I do is I have a very thin lip of metal on the outside, and so it makes it simpler to cut. And with the Dremel tool, sit there all day trying to cut through an inch of brass. You've done all that with the boring bar, so you just have a little lip around the edge, and you can cut that and keep trimming it until it fits nicely on top of the jacket.
Okay. Thanks.
I hear crickets. No one else? Anybody else there?
Well, I'm here. I
Here,
don't have any
Andrew.
questions. You've done a very good job with the presentation, Andrew, and it's enlightened me quite a bit.
This is a journey you are going to be taking yourself. I can give you here. This is what I'm talking about, the ejector. This is interesting. The ejector's here, and part of the ejector is up in here into the steam dome. This is I would say unique, but it's quite unusual from these engines. Yeah, they say this is the thing I can point you in certain directions, like how to do the drivers. Tom Mix gave me the information on it. I could do, I'd say about 95% of it very well, but he gave me the last 5% that made a difference in make it really a quality project out of it. And this is, you want to ask him, I'll be glad to, anybody wants to email me a particular question, I'll see if I can answer it, or you can talk to somebody else. I'm not a machinist. I have never taken a class in machining. This is all self-taught. And so it's dual. But one thing you want to do when you're working on this is you want to be able to look at this and be able to see how all the parts fit together visually. I mean, it may not seem like a lot, but you want to be 5, 10 steps ahead of what you're doing. You want to know this,
Going
I'm
from the
making this,
bathroom,
and
trying to
how
get
this fits into the machine. This is the
so just
machine.
tape over it, and I don't care.
And the other thing you
Put
want to do
some
on this is you make sure there's nothing I put together.
Edison.
Excuse me. There's nothing I can put together I can't take apart. I learned that was dealing with Pontiac engines in Richmond, Virginia. My first major job was, working on car engines. You don't build something you can't take apart because sooner or later you're going to have to take it apart. What I'm doing, the bar down here on this and put these in here, these come apart over and over and over again. because I got to take it apart here to mount these on the axles when I put the drivers together. So, I mean, that's just one example. You want to, again, make sure you take the motor out. How do you get it out of there? All the rest of the stuff comes apart. Any questions about how to do the drivers? Because this is probably one of the most crucial things you can do. That and the bearings are absolutely crucial to having a successful running engine. I guess if I overwhelm somebody or they understand it all.
Well, I do have a question, Andrew. When you're working with the lathe and all that, are you using any kind of lubricant between the cutting surface and the material you're working on?
Okay, when you're cutting on the lathe or on the mill, using the mill ends or drill bit, the boring bar, no. If you're using a drill bit into the thing, yes, but not for boring or cutting. If you're doing a tapping or die work, yes, you go to, where is it up here? This big nasty bottle here. I bought this stuff and have never used it all. I still have a lot of oil in there, but this is what you need is a cutting oil. And that'll save your taps and dies and your drill bits. You know, a little dab will do you, so to speak, especially when you're using these on your, um, let's see, what do we got here? Sorry, trying to get through here to this. Using this. You want a little bit of oil on the center bit, clean it up and rotate the thing around and a little drop each time you go. But when you come back for the use the drill, you want to make sure the bit goes into the hole you've already created with the center bit, put a little drop of oil on it, and then run it through. The bits will last a lot longer and get a better cut. But if you're boring, uh, say you're boring this thing out here. No, you don't use it on the boring bar, or when you're cutting outside this, you don't use any lubricant. Now, one thing I didn't bring up on this, there is what they call a cutoff tool. It's a flat blade. This piece goes perpendicular to this. The blade goes in and used to cut it. You use cutting oil for that. Most definitely. You flood the cut with oil as you're cutting a piece. Say this, you're like you're doing your uh, let's see. I hope I'm not losing any people going through this so quickly. I'm not sure exactly where. Oh, here. When you're cutting these, okay, and this, you're slicing this off, and that's what you use your cutoff tool. And you may be cutting only this, 160, under 35 thousandths, and you want to cut through this. And when you're cutting in here, this is not the tool you use. It's another tool like this, and has a flat piece of cut tool comes out, and it goes into the groove, and you cut it, and you slowly feed it, and make sure it's flooded with oil. That Ernie?
Yep, you answered my question. Thank you.
Okay.
One more little question. What do you use to make sure that the frame is parallel?
You use the frame as what?
Parallel. All the axles end up exactly parallel.
Oh, okay. All right. I just I didn't bring that up, did I? Okay. What I do for this, when I have, okay, this is your control point, and every one of these are exactly the same on every frame you've made. Okay. All right. All right.
Yes.
Okay. All right. So you're going to have two pieces of framework here. Well, this is where you use your machinist square. Where is it? Here you go. You set this on a piece, you lock this on a piece of sheet metal, like a piece of aluminum or something, sheet metal that
Uh-huh.
you use as the base. It's flat, hard enough, and it gives you a perfectly flat surface. You lock this on there, and then you put one frame on this side, and you figure what your spacer is going to be, and you cut that and make sure it's exactly right. So you have a little play between the drivers. It slides back and forth the frame a little bit, and then you put the other piece of frame against this, and you can solder the piece. This is what you use to make sure that it's perfectly square. But that's a good question because it has to be perfectly square, and that's why you use this.
I mean, I've seen a few gadgets that people use for that. With uh, basically, you mount the two frames, which you basically make them together so that they're actually identical, both sides, and then you'll mount them on this gadget, and it'll.
When you're doing the frames, each one of these is exactly the same. Exactly.
Mhm.
That's the reason why I said when you do this, you have your true position is always measured from here. Now you can pick another place on the frame to do it. You can do it from the front. I just do it from the back because it's easier. But every frame is exactly alike. There's no variations in it. If there is, you got a problem. And all you got to do at that point is make sure that this true point here, the end of the frame, is in that square with the other one, and it's perfectly perpendicular. And you put your pieces in the middle, and you wind up with this. As I said, there's always another way to do it. There's no actually one perfect way, but there is no way other than measuring from true position. Every one of these is exactly alike. As I said, I made 26 frames pieces, and every one of them came out exactly right, and it works. I didn't throw any of them away, and the hinges are all worked very nicely. I put it on top of my freezer, and I push it, and it rolls along as well as any car does. And that's worth all the mechanism and the side rods in place.
Have you found any reference material on this, on making or manufacturing brass?
About machining,
Yeah, no, machining in general, I'm sure there is, but specifically about scratch building model brass models.
well, I told you I wrote
Brass
an article on this for MR. It's like modeling from photographs. It's about a 13-page, 14-page article I did.
Okay.
I think there's somebody else has one out now, another magazine article on doing this.
Yeah, the only I'm talking about books and reference, so that you don't have to learn everything yourself, and you might find some tricks. And I couldn't find anything in the US. The only things that I could find were from the UK. And there's a guy, actually, he's passed away. He wrote a two-part book and passed away in the middle of the second part, so it's not exactly complete. But his name is Jeff Holt, and it's about scratch building locomotives. He was a very known builder in the UK. So
Are you asking for, somebody else to give you advice how to do this? Is that what you're asking?
well, reference book that basically describes, well, your first session, I understand, was on all the tools, and so he goes methodically, gives you
I'm
methods.
not expecting you're asking other questions. I mean, that's fine. You want to go
No, I'm just asking if you are aware of any other reference material, like books about it or anything like that.
No, as I said, this was self-taught, and I also have um I'm not sure if he's open to speaking to anybody or maybe if he's still alive or not. Tom Mix in I think Monument, Colorado. I will If you hang on a minute, I'm going to get out of this. Let's see if I can show you a picture. Well, he, you look up Tom Mix on Proto 48.
Okay.
He is probably the premier engine builder in the country at this point, if he's still alive. He models Quincy stuff for the most part, and it's actually exquisite. I actually had his framework showed in here, and it's beyond belief to look at it. But again, he's an artist. I built my engines because I needed them. He builds them as a hobby, as that's his hobby. This is not my hobby, so to speak. I built these because I needed it for the layout I was going to build. If you understand what I'm saying. Yeah, if you somebody asked me one time if you can buy one of these engines in the store as opposed to building one, if that's all you want is the engine, go buy it. It's a
Yeah.
lot cheaper than doing through all this. But if you cannot buy it and you like machining, well, this is a very infectious hobby. I've enjoyed every minute of it. I love it. I mean, I was, you know, back, I think about 60, 59, 60. I remember seeing the first ad for Unimat, and it just absolutely thrilled me to look at it. And I knew enough not to ask my father, to have that for Christmas because he wasn't going to do it. But I wanted to do machining ever since then. So I saw that stuff. And to say this stuff is in the shop. Also, when you're doing this in the shop, if you're going to get these, make sure you can sit down in a chair. Don't want to stand up. As people get older and older, the standing up is going to get old real fast. So I make sure that I have the lathe on a desk and I have the mill on a bench. Also, one other thing I would make point here is make sure you have plenty of light to see what you're doing. Um, I have several sources. I use a flood lamp like this, and I also sometimes use a spot lamp like this to illuminate what you're doing. You have to be able to see it very clearly. And you're gonna have to get your face fairly close to look at it unless you got special X-ray eyes to see it. You wear a pair of glasses, protect your eyes from any material flying around, um, but you need it very well illuminated.
Does anybody else have any questions for Andrew?
Let me show you the let me show you the picture here of Tom Mix's frame. Do you see that?
Wow. Yes.
There it is. Yeah. And if building your locomotive and that's your sole hobby, frame, whatever else, yeah, that's fine. Go through it. It says beautiful work. I mean, he sells some of the stuff on Allegheny, um, the Allegheny company, I think it is. He says sold some of his locomotives for, I mean, they draw thousands of dollars. I mean, here's his caps. You have the thing extended down below that, and the thing fits inside there with the cap, and it ain't gonna move. And of course, here's the drill hole here, where you have put the bolt up through the bottom, hold it in place. Again, be very careful when you're doing the frames. You never open this up until your caps are made and in place. Then you open it up. Otherwise, the frame will bend. I mean, the stuff will bend on you if you're not careful. Also, when you're doing your milling, make sure you see virtually no chatter marks in here where he's machined it out. That's the reason why you use to cut very slowly. You maybe like a 10,000th of the time, and only one piece of brass at a time. Not you don't cut both these frames at the same time. And you're asking to do too much work, and it's going to shatter. You'll break the bit or both.
Okay. Well, there's no other questions unless Andrew has something else he wants to show us. That's our That's our clinic for the day. And Andrew, appreciate you taking time out of your schedule to
No problem.
show us what you did.
How many people did you have on this thing today?
We had 7, but we have recorded this.